Okay, we're going to talk about solving equations that start with a log. The first method is called equating the logs. If we look at something very simple, like if the log of x is equal to the log of 4, doesn't it make sense that x must equal 4? Because you're taking the log, same base of two numbers, they have to equal each other. So we're using that idea when we have something a little more complicated. The log of 4x minus 7 equals the log of x plus 5. Now they have to have the same base. These are both log base 10. So because I have the same base, log and log, what's inside the 4x minus 7 has to equal x minus 5. So 4x minus 7 equals x plus 5 and minus x. So 3x minus 7 equals 5. Add 7. 3x equals 12. So x equals 4. So it's pretty simple. You just set what's inside equal. This is when you have a log equal to a log. They must have the same base. We won't deal with equations in Algebra 2 where the bases are different. If you do run across that, you might want to just graph them both, find where they cross. So the next one is when you have a log equal to a number or expression, we can rewrite it as an exponent. So if we have the log base 2 of 5x minus 17 equals 3, I can rewrite this. Remember, in the last video I made, we said that the log base 3 of 9 equals 2 can be rewritten as 3 squared equals 9. So we have my base 2 to my exponent 3. The 3 will be my exponent, and what equals what's inside 5x minus 17. We know what 2 to the third power is. That's 8 equals 5x minus 17. And we can just solve that linear equation. 25 equals 5x. Divided by 5. X is 5. If we plug it back in, it should work. Plug it back in, I get 5 times 5 is 25. 25 minus 17 is 8. The log base 2 of 8 equals 3. We're good. Let's look at another one. Okay, let's look at a natural log equation because those always seem to give us a little bit more trouble. Let's remember that the natural log of x equals 2 means, this is log base e squared equals x. And that's just how you would solve it. You plug e squared into your calculator. If it's a little bit more complicated, the natural log of x plus 3 equals negative 2. This, again, if I rewrite it as an exponent, is e to the negative 2 power equals x plus 3. And in my calculator, I do e to the negative 2 power. I get 0.135 equals x minus 3, plus 3. And then I'm going to minus 3 for both sides. And in my calculator, just hit minus 3. And I get x equals negative 2.865. Now there's one more method. Just like we were able to take the log of both sides, we can exponentiate both sides, and that's kind of a weird word, but what it means is to make both sides of the equation an exponent. And we end up, again, at the same place that we were using the other method. So let's look at a natural log one again. The natural log of 2x plus 5 is equal to, let's just make it easy, 1. The natural log is log base e, so I'm going to make both sides exponents on e. So it's e to the ln of 2x plus 5 equals e to the 1. And because e and ln are inverses, e to the ln of 2x plus 5 is just 2x plus 5, and e is 2.718. And to solve that, we'll just subtract 5. 2.718 minus 5 is negative 2.282 equals 2x, and then divide by 2, and x is equal to negative 1.141. Looking at one that has a log of a base, let's say log base 5 of x minus 6 equals 2. So this is log base 5, so each side is going to become an exponent on a 5. So 5 to the log 5 of x minus 6 equals 5 to the second power. And 5 and log 5 are inverses, so 5 to the log 5 of x minus 6 is x minus 6. 5 squared is 25. Add 6 to both sides, and x equals 31. Both the exponentiating method and the rewriting it as a log give you the same answer. I still end up with 5 squared equals x minus 6, as if I rewrote it as an exponent. Lastly, we're going to talk about when we have to use a property to simplify first. So we have an equation where we have more than one log on one side, 6x plus the log base 6 of x minus 1 equals 2. So I have two log base 6's. They're being added together. I can use my product property to rewrite that as the log base 6 of 6x times x minus 1 equals 2. Now I can rewrite it as a log. 6 squared equals 6x times x minus 1, and that's 36 equals 6x squared minus 6x. Now remember, whenever we have an x squared and an x in the same equation, our first resource is factoring, and our last resource is quadratic formula, completing the square. So we have to subtract the 36 to make it equal to 0. So 0 equals 6x squared minus 6x minus 30. We can factor out a 6, x squared minus x minus 6. And 0 equals 6 times x minus 3, x plus 2. So x has two answers, 3 and negative 2. Now we have to remember one thing, that the logarithms have a domain function. You cannot take the log of 0 or negatives. So we have to take our answers and plug them back in to see if we get a 0 or a negative. Now this usually happens when we end up with an x squared equation. We have to put more than one equation together, or more than one log together. So when I take negative 2 and I plug it back in here, I get the log 6 of negative 12, which is not allowed. Put it in here, I get the log 6 of negative 2. Again, not allowed. So that's what we call an extraneous solution. It's a solution to the quadratic, but when I plug it back in to my log, it doesn't work. And that is an extraneous solution. The 3 works because I get 18 here, and I get positive 2, so I can do the log of both of those. Let's one more example. The log of 2x plus the log of x minus 5 equals 2 times the log of x. So in this case, I have logs on both sides. Once I condense both sides, then I can set what's inside equal to each other. So when I condense this side, I get the log of 2x times x minus 5 using my product property. And on the right side, I use my power property, the log of x squared. I have a log equal to a log, so I can say that 2x times x minus 5 is equal to x squared. And that's 2x squared minus 10x equals x squared. Again, I have x squared and an x in the same equation, so my first thought is get them on the same side to see what I'm dealing with. X squared minus 10x equals 0. Factoring, square and an x squared and an x, factor. X factors out, x minus 10 equals 0. So my x can equal 0, and my x minus 10 could equal 0. So my two answers are 0 and 10. And I plug them back in. I plug in my 0, the log of 0. Can't do that. Plug in 0 here. Log of a negative 5. Plug in 0 here. Log of 0. My 0 is extraneous. Does my 10 work? Log of 20. Okay, that's okay. Log of 5. That's okay too. Log of 10 over here. That works. So my answer is just 10.